Okay, let's continue and with the type of functions that we are looking at. So it is important we understand the types of functions we have in economics, business, and other social sciences. We need to understand the relationship between those variables that are involved, and we need to know some of the characteristics so that when we do some calculations, we will be able to give some, we will be able to give economic, business, and other social science interpretation to those numbers. The goal here is not about only calculation; it's about the intuition that you will build, to be able to give interpretation to those numbers that you have calculated or that you will calculate. So let's continue with where we stopped with the supply function. Uh, we were talking about two, that's B, that is supply function. So we say supply functions is just so the relationship between price and quantity is supplied, and we went further to say the relation, what is the nature of the relationship between the price, and this is represented with that is S as a function of X, and the X there we said is nothing but quantity supplied. In some books, instead of X, you will see quantity supply. So we have X here, and we say this is nothing but quantity supply. So we said, what's the link, the relationship between price and quantity that is supplied? So basic economics, will have learned that when price increased, then the X, which is the quantity supplied, obviously will increase. And if price goes down, obviously sellers won't be motivated to sell more. So the quantity that they will supply to the market, which this X is quantity, so will go down. So you will see that if price increase, quantity supplied increase. So the arrows are pointing in the same direction. And because of that, we said they have positive relationship. And with graphs, or geometrically, when two variables have positive relationship, the arrow will be, the graph will be upward sloping. So normally for supply, we have to go to the negative quadrant. So we will have something like this, but this will become clear to you. So this function is supply function. So we need to know this intercept and also the q-intercept. This is the price intercept. In mathematics, normally we have y here. So this is y-intercept. We need to know how to find this. This is what x-intercept. We need to know how to find this. Normally the x-intercept for supply is always here. We will talk about this. We will take some practical examples and do that. Now that we have, we talked about supply demand function, we talked about supply function. We said that the relationship between them is positive. That's why it is upward sloping. What we need to know how to calculate this and how to calculate this. So we have, if you looked at supply function, it is telling you the behavior of what? The behavior of suppliers in the market. Or the behavior of farms in the market, the same meaning, or the producers in the market. While the demand function, that is D of X, is showing you the behavior of what? Consumers. Or what? Households in some textbooks. So now we want, if we bring the behavior of these two economic agents, we have something called market. So let's look at the market, whereby demand and supply functions are brought together. So let's look at a market. So in a market, if you are studying market, you are just trying to study the behavior of buyers and sellers. So normally, graphically, we can represent it with equilibrium. So here we will have demand curve. This is our demand curve. So then we will have our supply curve. So where they intersect, like here, so this will be what? The equilibrium. So here, this equilibrium, quantity demanded is equal to quantity supply, and the equilibrium price will be this. So we should be mathematically, we should be able to calculate this. We should be able to calculate this. We should be able to calculate this. We should be able to calculate this and this. We will take a typical example. The assignment I gave it to you, normally I ask you to calculate only this. But maybe the next assignment, it will go further, whereby you have to calculate all the intercepts as well. So we look at the demand function, we look at the supply function. Now let's look at the revenue function. Let's look at the revenue function. So revenue function, normally we use this symbol to represent it, R of X. This X is telling you revenue, it depends on the quantity that you produce, or the quantity that you sold in the market. Actually, it depends on this. We assume that this is what? Quantity sold in the market. So normally the revenue function, the formula is what? It's the selling price, SP, selling price per unit, times what? The quantity sold. So the quantity sold, we represent it with X. So at the end of the day, the revenue function, that is R of X. So this selling price, let's represent it as P. So this revenue will be what? Selling price per unit, that is P, times the quantity that it sold in the market. So to find revenue, this is what you do. If you know the price and you know if you know the price, you just multiply it by the quantity that is sold, then you'll have the revenue. So let's look at it graphically, geometrically. Let's look at it how it looks like. Obviously, it will be only the positive quadrant. So we will have something like that. Remember, they say revenue is a function of quantity sold. So this will be X, that is the quantity sold, then the revenue will be this. So obviously we know that if the quantity sold is 0, then 0 times P, it will be 0. So this has to start from the origin. So you will have a revenue function like this. So this is our revenue function. It looks like this. So it's another important function in the business world that we should understand. So the formula is the selling price per unit times the quantity that is sold. So another function that is important is what? The cost function. So we will see a lot of application where we will talk about cost function. They will ask you to drive cost function, or profit function, or to calculate the revenue function, things like that. So knowledge of it is very important. So we represent cost function as C of X. So what it means, C of X, for this case, the X here is what? The unit produced, or the quantity produced, or the number of items produced. But remember this cost is what? Is the total cost function. Total cost function. But we know that total cost is a summation of what? Variable cost plus fixed cost. Those who have done accounting, especially cost accounting. So cost function. So how do we calculate? Then we have to know how to get variable cost, the formula, and this also as well. Variable cost is what? Is the VC, that is VC mean variable cost, is variable cost per unit. That is, what is the cost of each unit that you produce? Then multiply by what? Unit produce, that is units produce. So if we said that, we can take this as VCU, that is variable cost per unit, and unit produce is X, then our variable cost will be what? VCU, that is variable cost per unit, times X. So what about fixed cost? Normally fixed cost, the name itself is self-explanatory. It's just fixed. It just take a number. There is no particular number to it. So at the end of the day, our total cost, which is a function of unit produce, will be this fixed variable cost, that is VCU, multiply by X, then plus variable cost. Let's look at a good example. Graphically, this is how it will look. X, that is the unit produced. Then the total cost, we have it here. So because fixed cost is fixed, let's assume it's here. And variable cost is we only incur it when we produce. So it has to start from here. So at the end of the day, for example, let's take a practical example of a total cost. You can have a total cost like this. Maybe we have 2x raised to the power of 2 plus 4x plus 10. So if they say this is a total cost, so the variable component will be this. Because we have the variable here, x, which is the unit produced. So this is the variable cost. And this is what? The fixed cost, the 10 there. So for example, this will be 10, then you have the variable cost. Very important function, cost function. So from there, another important function that we should look at is profit function. So calculation is nice. Sometimes visualization also helps you to remember. So let's look at profit function. So profit function, there are two representation we can use. It can be represented by P of X, but some people also use pi to represent this. So in some textbook, you will see pi to represent profit function. So it's very simple. Let's use this for this class, that profit function. Obviously, profit is just the difference between your total revenue and your total cost. Total revenue and total cost. So we have this. So another function that I want us to look is average functions. average functions. So when we talk about average function, we can have average cost function. So how do we calculate that? Average means division. So we have to divide total cost by quantity produced. We can also find average revenue function. How do we do that? We divided total revenue function by X. That is the unit sold. So we can also have average profit function as A, P, X. So we take this profit function here and divide it by X. So we have up to 6 functions that we looked at, and we look at some of their characteristics and their formulas, and we will be using some application to calculate, to derive these functions. So now we will go on and do one practical example, and then we close for the day. We close for the day. So let's take a look at this example. So let's say that you have this example in the materials I share with you, the functions, those materials I share with you. The example is there, but this is it. What is there is that they give us P of X. Remember that we said that the profit function is represented as this, but sometimes in some questions things can change. Here the P of X is not the profit function, but what is the price. So the price of a coffee is represented as this formula, that is minus 0.27x. This is given to us in the question, plus 51. Another thing that was given to us in the question is that the cost function. If we check those material, you will see this example equals to 2.23 x raised to the power of 2 plus 3.5 x plus 85. So in the question, this is given to you. So this is what total cost function. They gave us this in the question. So the X there is what is the production, is the quantity of coffee that is produced. Let me even help you. Coffee quantity, QTY of coffee. So here the tax, they tax us to find what? A part says that they ask us to derive RX, and we know RX is what? Revenue function. Also, they tax us to find what? PX. So this time the PX here mean the profit function. So this is profit function. They want us to find it using this information. So what they are telling you that the cost of producing a coffee is represented by this equation. Maybe an econometrician just did some regression and came up with this function. So the cost of producing, total cost of producing coffee. You can read the question to have more gist. Total cost of producing coffee. So this is the price of coffee. So they said using these two information, let's calculate or derive revenue function and profit function. There is second question, but we will look at that after driving revenue and profit function. So obviously, this is revenue function. Okay, so let's look at revenue function. We have revenue function like this. And the formula is what? Is the price times what? Quantity. This is the formula we talked about in our previous slide. So if that's the case, then equivalently, we can compute revenue. That's revenue quantity, which is here. You just take quantity, then multiply by what? The price. And this is the price of coffee, which is 0.27 x plus 51. So then the revenue will be what? Minus 0.27. This times this will lead to x square plus 51 x. So we have a revenue function. So by now you should know what type of equation is this. We have talked about this. Obviously, it's quadratic. The revenue function, quadratic function, not equation now. So we will also look at how do we graph quadratic equations. We will look at this as well in this course. How do we graph this kind of graphs? But obviously we know that it's a maximum. Those who have taken calculus before, this alone will tell you a lot about a graph. But we will see it if time permits us in this course. So going back to the question, now we have known this, that is a revenue function. Now let's look at, let's calculate or derive the profit function. So we said in the previous slide that profit function is what? Revenue function minus cost function. So then we will have P of X, and we know that our revenue function is what? Minus 0.27 x raised to the power of 2 plus 51 x. Then minus the cost, we put it in bracket. And we know our cost already is this one. So we use that. Then 2.23 raised to the power of 2 plus 3 minus 5x plus 85. So obviously, what we will do, we collect the like terms. Remember that this is 0.27 raised to the power of x raised to the power of 2. So this and these are like terms. So you just said minus 0.27 x raised to the power of 2 minus 2.23. You will have the answer. So we also looked at this one and this one, they are like terms. So it will be what? 51x minus 3.5x. Then we have only one constant here. So if we do all those, we simplify those expressions, we'll have P x equals to something like minus 2, that is minus 0.27 x raised to the power of 2 minus 2.23 x raised to the power of 2. We'll have minus 2.5 x raised to the power of 2. Then with this and this, then we will have plus 47.x. Then we have our minus 85. So this is our profit function. So we have finished the first part of the text. We have this. So, yes.
How did you get the 47.5? I think you are adding the 51 plus. This 51 plus 35.
No, it's 3.5. Yeah. But remember, there is a minus here, so this will change.
I thought it was 35. I was writing 35. No, it's 3.5.
Yeah, it's 3.5. Yeah.
Okay, I got it.
Okay, this also is point, by the way. And this is this point. Okay. So we have this function also. And if you looked at it, it's what? Quadratic function. The profit function is quadratic. And by now we should be able to know why quadratic. We spend a lot of time with equation. This is quadratic function. So we have talked about quadratic equation is the same thing as quadratic function. But what we haven't talked about is how do we graph them? So we will look at this in the future, how we graph them. So going back to this, we have solved this as well. So the B part of the task is they touch us that we wanted to know at what level of production of coffee is profitable, at what range, you know, because if you looked at production, in fact, I will take bit on another slide. Let's say that tax B is asking us what? For what value of X? We know that X is what? The quantity of coffee produced for what value of X is PDT means production, by the way. So for what value of X is production of coffee, profitable? So we have 10 minutes, so I will beat Ross this, but if you don't get it, we will repeat it again next class. So all what you need to do here, you understand, the production of coffee is profitable only when the profit function is greater than 0. But this might confuse you in that the material I share with you, they said like this, but I will go with this. First, let's determine whereby the profit is 0. If we know where profit is 0, then we will be able to know where profit, you know, we want to hear what we are determining. We want to know at what value of X, at what production of coffee, the profit is 0. If we determine that, then we'll be able to know where it is profitable. So what you do here, we have our profit function already. We can bring it. So the profit function is minus 2.5x raised to the power of 2 plus 47.5 x minus 85. So all what we need to do, we replace this P of X with 0, like this. We wanted to know at what quantity of production the profit is 0. So to do that, then we will have our quadratic equation. This is 47 minus 85, equate it to 0. And why are we doing it? We want to know what value. So when the time goes off, we will stop there. Next class, we can continue with this. So now, dealing with decimal can be so horrible, it can be very, very difficult. So what I want to get rid of this. We divide both sides by all the terms or the expression by minus 2.5, minus 2.5, minus 2.5. So this doesn't change anything to the equation because we did the same thing to the both sides of the equation. So we cancel this. So this will give us x raised to the power of 2 plus 47.5 divided by minus 2.5. That should give us 19. Yes, should give us 19. Someone can confirm it, please. So, and this should be negative instead of
negative 19.
Yeah. Positive. So we have this negative 19, not positive. So this would be negative 19. So this is minus would give us positive 85. Then this should give us 34. So this would be 19x plus 34. Obviously, this would be 0. So we have x raised to the power of 2 minus 19x plus 34 equals to 0. Now we have this. So to solve this, you have different methods. You have quadratic, general quadratic formula, completing the square, factorization. So I will quickly use the factorization before we run out of time. So here, if we factorize it, we'll have x minus 2 and what? X minus 17. You can use your general quadratic. At the end of the day, we'll have the same answer. So at the end of the day, this will be x minus 2 equals to 0, or x minus 17 equals to 0. So at the end of the day, x equals to 2, so x equals to 17. So the question was at what level of production? So between 2, that is x equals to 2, to 17, this is a level. Here, the profit will be 0. That is when x equals to 2, profit will be 0. And you can confirm that by substituting 2 into this profit function. You will realize that if you substitute there, what you will have, it will be 0. If you also substitute 17 there also, you will also have 0. So here also, when x equals to 17, the profit will also be 0. So it's only between here, before, is after 2 and before 17, where production is profitable. This is mathematics. Let's try to visualize this and see. So with quadratic, let's quickly do this before we run out of time. We have profit function. So it is telling you that here, when x, that is the quantity, this is x, quantity of coffee produced, when x equals to 2, and when x equals to 17. So you will have something like this. This should cross here. I'm terrible when it comes to drawing graphs. This. So at here profit is 0. At 17, profit is 0. But between 2 and 7 is where we make a profit. Before 2, profit is what? Remember, this is profit function. I will tell you how I draw this in the next class, but I just want you to visualize it for now. So at here, between 2 and 17 is where production is profitable. If they produce 2 quantity of coffee, the profit will be 0. If they produce 17 quantity of coffee, the profit will be 0. So, but if they produce beyond 17, you see, this is negative. Beyond 17 here, the profit is this, it becomes negative. Before 2 also, like if they produce 1, if this is 1, the profit will be this, which is negative. So it's only profitable between, production is only profitable when the quantity produced is less than 17, but is greater than what? 2. So what is the maximum profit? They can even ask you for that, but we will leave that until next class. We will do the B part again for you to understand more. So we will stop here until next Saturday, and then we will, revise the B part. Then we'll have more real life application. If you have any question, you can ask before the times goes out. Any question? So meaning that you understand perfectly, huh? Everyone is understood.
Yes, sir.
All right. On that note, have a happy weekend, and please protect yourselves, your families as well, by being by adhering to the guidelines that the health workers put in place. And have a happy weekend, and see you next Saturday.
Thank you.
All right.
Thank you.